Hey Manjush, can you hear me? Hello?
Hello? Yeah, I
Yeah.
can hear you. Yeah, I can see your screen now.
Okay, so I have started recording also.
Yeah, thanks.
So now you can see the screen, right? So what I was
Yeah,
doing is that I was showing a example of the limit operation. With the help of
yeah,
limit operation, we basically limit on how many elements we are actually going to operate upon, right? So sometimes there is a requirement that we want to operate only on 10, or let's say streams you are getting, right? There are a lot of elements, and
yeah. So it is like, is there any functionality to start, like, just like pagination, or how
yes,
we do? Like, when we come with limit, then if I can limit with 10. So is
exactly.
there any functionality to start the element from 10th element to 20th element or something like that?
Yes, yes. So there is. So that's what I'm coming to. So I mean, you took a perfect example, right, of
Yeah.
elimination. So there is a functionality called if you say skip. So this is what we will do.
Oh, okay, okay.
So if in fact we can just write a pagination function, right? So paginate it will what do it will take start and it will say number of elements per page, right?
Yeah.
So this is something. Let's say you are creating a web application, and in that web application you are actually going to create a, and what I will have is a, this is my dummy list, and this is something that I don't need, so I will skip from wherever I have to actually start, and I will limit it with
Yeah.
pages, and this is it.
Yeah, that's cool. Okay.
So this is why basically functional programming actually becomes cool, that you declaratively tell skip, right? You declaratively tell
Yeah.
commit, you declaratively tell okay, collect, you declaratively tell call this function on each member of the stream. So this is the reason that many people prefer functional programming, and that is the primary probably the motivation that Java 8 has actually brought these features.
Yeah.
Okay. And let's say rather, so right now we are printing, right? So rather than printing, let's say I want to return the list of the cars, right, in a paginated fashion. So what I will do is rather than calling the for each, I will call collect. So collect is the function basically which is a terminal operation. Okay. So for each was a terminal operation, and so is collect. And what I want to do is that I want to collect all this paginated results inside the list. So this becomes my exactly the paginated function that I will be using in the production code. Okay.
Okay.
So yeah. So we saw some cool application of now coming to the, so we have seen right different type of stream operations. If you want, we can even have a more. There are other helpful functions like min and max. Okay, so you can
Yeah.
get a minimum element out of the stream. You can get a maximum element out of the stream. Count is another useful utility that in general you have to. Sometimes you just need the count, right? How many elements are there in a particular stream? So
Yeah.
this is what the count operation do. But this count operation is different from the operation on array list. So on array list, when you get a length, all you get is a value of the variable. Okay, so that's like a very efficient operation.
Okay.
Okay, but this count actually does the count it, so it has to basically kind of iterate the entire stream and then return you the counts. Okay, because
Yeah.
streams do not store any data, right? That is the primary
Yeah.
difference between the streams and the data structures. So streams do not contain any state at all. So that is the reason that when we are doing the count operation in a stream and count operation on the data structure, the running time will be very different.
Okay.
So this one is important. Any match is like, so any match is like a filter operation, right? So it takes the same predicate. If you see, difference between filter and any match is that, filter basically returns you all the elements which actually match a certain condition, right? And any match, what it does is that it will return you if there is any element which actually matches this particular condition. Now, if you look at the Java doc of it, it says returns whether any elements of this stream match the provided element. So it may not evaluate predicate on all elements, which is different from filter. So filter operation, it applies the same predicate on all the elements.
Okay.
Okay. So, and when you go, so when you need, something, then first you have to go to the stream interface. Depending on your business use case, you will actually try to find a relevant operation, and that's what you should actually apply. That is the practical way of going about it, because it's not possible to remember all these functions, right? um,
Yeah.
so you should go to the stream interface, open this class stream.java, and then look at all the go through the definition of all the interfaces, and then see which function actually I want to utilize. So this one is important. Find first. Now this is something that we actually. So by the way, do you want to take a break now, or shall we go ahead?
Shall we take a break? I'll go and have a
Okay.
coffee and come.
So 10 minutes should be sufficient, right?
Yeah, yeah, fine. Thanks.
Okay, great.
I'm back.
Hello.
Yes, I am back. Um,
Hey,
yeah.
hey, Manjush. Yeah.
Yeah.
Okay. So Manjush, now we are going to. So we discussed briefly, right, about this optional keyword, right? Now, if you see the new code in Java 8, the people that are writing, you will actually see a heavy usage of this optional. And
Okay. Fine. First. Okay.
right, so optional is basically nothing but it's a way to protect the null pointer exception. So
Okay.
right, so whenever we return an object, so if I say an example, let's say what I'm going to do is public car, find my car, find car by brand, right? Let's say I'm doing this. I have a list of car, which is car list, and I have a string brand. So in general, so I am writing code in Java 7 style, right? Car dot equals brand return. In fact, this was a common type of code, right? Either you can return from here or you can return from here, right?
The sound is not that audible. It is
Oh,
breaking.
okay, so is it better now?
No, it is. It is breaking.
Breaking? It should not break.
Yeah.
Okay, let me unmute and mute again. Is it better now?
Yeah. Now it is okay.
Okay, so basically what I'm trying to do is that I've written a small function find car by brand in Java 7 style, correct?
Yeah.
So I basically iterate on the car list, and whenever my brand actually matches with the brand that I'm looking for, then I say I store it in the variable and then I return that variable, correct?
Yeah.
Now what will happen is that let's say this condition never actually gets true, right? So my code will never go inside it, and what I will return is a null because I
Okay.
initialize my find car as null, right? And someone, let's say I ask you to use this API, you call this function. So what will happen is that you will actually get a null pointer exception, correct?
Yeah.
So in order to avoid that, right? How do I make sure that the programmer who is actually calling this function find car by brand should actually check whether I am returning a null or not? He should actually check for the return null value. Then only you
Okay.
utilize this function, right? Otherwise, I will get a null pointer exception. So right now there is no way for me to communicate other than the Java doc, right?
Yeah.
So what I say is returns a car whose brand name is right. Then I return like this. So the only way I can actually communicate whether this function is going to return null in some scenario is through this statement, may return null. So programmatically, I need to have a way by which I can tell the callee of my function that I may actually return a null. So what is that way, right? So that way is nothing but a optional keyword that has been introduced new. So what they say is that just in case you are assuming that there is a possibility that you may return some null, rather than the object, you actually return an optional of that object. Okay, and when you actually initialize, So the way the function signature will change is this: optional of car. I initialize it with empty. So this object that the optional will actually return. This is not null. This is empty.
Okay.
Okay, so this is still an object. So you will never get an optional. So you will never get a null pointer exception when you are actually calling. Now, rather than find car, you have a car. So this is something you will have to change. Optional dot off. So what you do is you return a find car, and in your calling, when you are getting a find my car, so it's a car list, and I have passed the brand. Let's say BMW, right? So what is the error we are getting? Okay, so this function is not static. Right, so I do this. Now what will happen is that now I am the callee of this function. I know very well that this function is actually returning an optional, meaning the value that is actually returned to me may be there, may not be there, right? So now I what I will have to do is find my car dot is present. If it is present, I say car, my car equal to find my car. Okay,
Yeah.
you got the difference, right? Now programmatically it has been communicated to me that the value that returned by this particular function is actually an optional.
Yeah.
So I know that I have to be careful here. I have to check whether the value is actually there or not, and
Yes.
I do that by calling is present function on optional. So is
Yeah.
present function will, so basically if you look at the implementation of this, when this line is called, is optional will be false, is present will be false. Okay,
Yeah.
but when this line is called, is present will become true.
Okay.
Okay, so I know that if is present actually returns me true, there is definitely value inside it. So this is just
Yeah.
a what I would say, safety mechanism or defensive programming that has actually been introduced inside Java 8. So it's a container class. It's not. It does not do anything extraordinary. It's just a container class.
Okay.
Okay. So now, if you see that this find first, if you look at this find first function,
Yeah.
this will actually returning you a optional. This is the reason that it is actually returning you an optional, because the condition that you are actually passing as part of your
Mm.
stream, that condition might never get executed, right? None of the objects, if it does not satisfy that condition, then you cannot
Yeah.
get an object. What you will get is an empty. Okay, so I will show you an example of this if you want. So when I say filter by color, then I say find first, right? So let's
Yeah.
say the stream, if the stream is empty, then what will happen? If the stream is empty, then obviously you are not going to get anything, right?
Yeah.
So what I use, so find filter by color. What I say, start to return. So what I'm doing here is that filter all cars of this particular color and return me the first car, right? That is what I'm trying to do. But
So
if this,
basically,
sorry,
it is a very consuming, like, the requirement may be to filter all the cars. So in that case, if we just go and add find first just for a null check, then it is uh, it's a big heavy load, right?
I mean, yes, you can say that, right? So there are, yes, pros and cons, but I mean, so in essence, you are right. Um, but from a Java designer perspective, the person who's actually designing the language, he's thinking from a different perspective, right? He's thinking, what is it
Mm.
that most people actually want to do? They say that most of the time people are getting null pointer exception. How to avoid that? So let me introduce this new class. Now, whether to use it or not to use it is up to you. So if you have a
Yeah. So
case that where
if
you
there is, yeah, basically we just go for a null check, right? So just
yes,
in
yes,
just
definitely.
one if condition problem got solved.
Yes,
Now it is becoming uh, more like programmatically we are adding, coming up with another class and then checking. So maybe errors may can happen in the way that we are going to come up with the optional thing. Because
yes,
sometimes our this null check, the thing that we are going to code that we are going to add for null check, sometimes that code may get make you some defect if you don't handle it correctly.
yes, exactly. I mean, I absolutely agree with you. A lot of people don't even like this class at all.
Yeah. No, like from the practical perspective, if you think uh, the possibility, see everywhere some human errors, like some errors that from something that happened. That's why this null check or some bugs that comes out. So naturally, when we go for another few more classes and check, and then maybe the possibility of getting an error on that area may be more. It can also happen. So that instead of just a null check code sometimes
Yes,
bring other errors also.
no, I definitely I'm with you on this Ben basically. But the that basically what is happening is that Java 8 design is actually influenced by other functional programming languages design. Okay,
Oh, okay, okay.
and most of them actually have this kind of class.
Hmm.
So yeah, so I wouldn't say that this is something that can actually prevent you from all the error. You can still get a null pointer exception.
Yeah.
So, but I mean, it is there, so it is there. The primary objective is this one.
Yes, 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 yes. But it's good to understand. Yeah, there
Yeah.
is one more option.
So these three topics that we have covered in detail. Lazy processing, I already told you, right?
Yeah,
All the internal operations, um, or all the intermediate operations, they are all lazy processing, and they are always returning stream. They do not result
yeah,
void. They do not return any collection. They do not return any map or anything. They always return stream. Hence, all the
yeah,
stream of all the intermediate operations, they are lazy processing by default, right?
yeah.
And now let's say, okay, sorting a stream, right? So let's see an example of the sorting also, right? Now what we want to do is, uh, let me. So what I'm going to do is, I am going to create multiple cars of the same brand. Okay. So I created this car. Let me create. In fact, let me create a helper function, right? Like y create. So what I'm going to do, going to create couple of cars with different brands, and then we are going to see how whether the sorting function works as expected or not. So I say create car, then I say BMW. I will delete all this. Now what I'm going to do is I'm going to call this Jaguar. I'm going to call this whatever Fiat. I'm going to call this GM. Then I'm going to do this. Right? And
Yeah.
here we are actually printing the car list. So what we are going to do is let me debug this. So if you see, sorry, we didn't get, we get, I don't know what happened. Okay. Oh, sorry, my bad. So when I execute this code, you see that, I get the cars in the same sequence in which I actually added them, right? So first is BMW, I get a BMW. Second is Jaguar, that's what I get. And then third one is Fiat, I get a Fiat. And then I get a GM, I get a GM, and then I get a BMW, right?
Yeah.
Now, let's say if I want, so we are going to see the sorted operation. Now, what we are going to do is car list, sorry, system println on sorted list. I have car list dot stream dot sorted dot for each c dot, right. Now let's rerun the program,
Yeah.
right. Now I run the program, you see I get an exception, right? An exception is very clear. When I want to actually sort my all the elements inside my the element that I am having inside this list, they have to be actually comparable, right? Otherwise, how will the algorithm actually know,
Yeah.
right? So rather than having a comparable there, sorted function has got two overloaded functions. So one does not take any argument, in which case the comparison happens through the object itself. Okay.
Okay.
So object is what? My object is car, right? So I can do two things. Either have a I can ask car to implement comparable, right? So
Yeah.
this is one way. So in this case, I will have to implement the compare to. Okay. For example, what I can do is o dot get brand dot compare to this dot get brand. Okay. Let's say this is my implementation. So this is one way. In this case, my program will just should just pass. Let's see if it does so. Now see, I did not get any error, right? But what I get is this,
Yeah.
right? So what I'm getting is the reverse order of the string,
Yes.
right? There is one other way that, just in case I don't want to have this. Let's say I am working with a class which whose implementation is not in my hand, right? My friend implemented some other package and I don't have access to that source code, correct? But I still want to sort that stream. So
Yeah.
sorted function actually provides me another overloaded function which actually takes a comparator. Now if you see, let me just, I can actually do this, right? What I can do is o1 dot compare, oh, sorry, o1 dot get brand dot compare to O2 dot get brand. So brand to brand comparison we are doing. We can even do better because sorted is a function which is basically taking a comparator, right? And if we go to comparator, it is a functional interface, right? And if it is a functional interface, then we should be able to pass a lambda to it. That was the initial concept, correct? So I should not be writing this. I can do even better. What I can do is in the sorted function, I can have O1, comma O2 and this. Sorry, it's not needed. You see this, right? Now my code looks like much cleaner, correct?
Yeah.
So in the sorted function, I actually pass the lambda. Now if I run my program again, I get natural string sorting. So I get both the BMWs together on top, then I get a Fiat because F comes after B and then G and then J, right?
Okay.
So this is the purpose of the sorted function.
Mm.
So you understood, right?
Yeah, yeah.
Now if we go to the next topic, so we have sorted the string and then this is important, saving results to a collection using the collect method. Now, like I showed you earlier in one of the examples, right, the paginate. So paginate example, this one, let me write. The paginate example is a perfect example of this one, saving results to a collection using the collect method. So when we are done with the stream, when we have created our pipeline, at the end of it, because stream operations are lazy, intermediate operation, we have to call a terminal operation. And in that terminal operation, what we want to do is sometimes we just want to print, right? When we want to print, we just iterate on it. So we just say dot for each, correct? But
Mm.
sometimes we
Okay.
want to collect all this result and then return them. In
Yeah.
that case, we have to we have to create a new list and we have to collect all these results into that new list. So in the earlier Java way, this is what we will do, and then we will keep iterating and then keep adding, right? So
Yeah.
if I want to do, let's say, some comparison, what I will do is in the old Java way, this was our thing, right? If for car list. So let's say I wanted to this sorry. So sorted car list or any car list for that matter, right? Let's say uppercase car list, correct?
Yeah.
So what I will do is uppercase car list and then let me just return a string rather than the cars. That will be better. Dot add car dot get brand dot to uppercase, right? This will be my way, right? So I keep adding,
Uh,
right? This is how I collect results in a new list. And if there is some condition, then I will do if and else, and then I'll keep adding, right?
okay.
If some condition, then add, otherwise don't add, right? Correct. So this is something that I will do in Java 7. This is how I will collect my results So whenever I have to collect my result, I have to explicitly create a new list because I do not want the old one because that had some more elements. But now I want to have only
Yeah.
some elements, right?
Yeah.
So I pass a condition and then I keep basically adding.
Yeah.
Now this is something similar. This has been like done nicely in Java 8 and the functional program. What you do is you create your pipeline, and after that you just say dot collect method, and in the collect method you have to pass in which collector you want these things to be collected, right? As you can see, collector method has this thing, right? So either you can have a set or you can have a list. So this one will actually return you the list. So if you go to the collector interface, you will see that what it is actually trying to do, right? So it's creating a new on the array list. So it is also creating a new array list, but it is hidden from you. That's the only thing. Then it is calling the add operation,
Yeah.
right? So I mean conceptually it's very simple, but syntax looks like much simpler. So at the end of the day, it is creating a new list. It is getting all those items, iterating them, and then adding to the list, and that's the list that it is actually returning. But the syntax looks much cleaner with the collect function.
Yes. Yes. Yes.
Right? So that's how we collect the results. Uh, okay, and then we come to the grouping and partitioning. Right? Let's come to this part.
Okay.
Okay. So okay. So grouping and partitioning data. Now let's take a use case. Okay. Um, I have a list of cars, right? And I say I have many cars inside my showroom. There are BMW cars, there are Jaguar cars, there are Fiat cars, GM or whatever. Correct? And they are all inside. I have entered all this information into my software, and then I actually want to find out. Give me all the cars, sorted by the brand, so that I can have different sections for them inside my showroom, right? Let's take a
Yeah.
hypothetical example.
Yeah.
So now in my software, I have to implement this that I have to group all these cars by the brand,
Okay.
right? So
Yeah.
what is it that the Java 8 functional programming techniques are giving? Is there any function, any API, any method which will basically help us group the data?
Okay.
Okay, so that is the whole intent of this grouping thing, and I will just walk you through one of the examples. Take this example. Right? First, I will walk you through the example, then we will basically write it again.
Okay.
Okay, so let me even comment it. Origin string. So what we are saying that with the brand we want to group all these items which are list of cars. So first we do a car list dot stream as we do usually, and after that we just call the. So now we are not doing any operation on it, right? Sorry, you were saying something.
No, 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 no. Then by from the stream we are using that collect function, and then we are grouping based on the brand.
Yes. So this part I want to explain to you. So
Yeah.
once we get the stream, then what is our objective? Our objective is basically to collect the results, but collect the result in a way that they are grouped by a particular attribute, which is the brand in this case.
Okay.
Okay. So in the collect method, you can actually collect method basically takes what? It takes a collector, right?
Yeah.
And there are many useful collectors which are available as part of the Java 8 APIs.
Yeah.
And one of the collectors is of type grouping by.
Yeah.
Now if you see this collector, then it is actually returning you a collector. So grouping by function returns us a collector, and this collector is of type what? This collector basically returns us a map. Okay,
Mm.
and the first type first argument type of the map is by the attribute by which we are trying to group. So we are trying to group by
Okay.
brand, and brand is a string. That is why we see a string here.
Okay. I was wondering because it is returning a list, returning
Correct.
a collection, and then how comes it is a map? And I was about to ask you that question.
So as you can see that basically when we are grouping by brand, then obviously that we have to keep all the brand. For each brand, we will have to have a list, right, of car,
Yeah.
and this is exactly the signature of this function. Map of
Okay.
from a list of car, and it is basically so the type of the string type, the key inside the map is basically getting inferred from the attribute that on which we are grouping.
Grouping. Oh, okay.
So this is
If we want to group based on two values like group BMW brand and group Maruti, then how it will, is it possible?
yes, yes, perfectly possible, right? That's the beauty of this Java 8 APIs. So let's say first you want to group by brand, and then you want
Yeah.
to group by let's say color. Okay.
Okay.
Okay, so what we can do is this particular grouping by function. So let me copy paste this right in this example itself. Now the name of the function is get. So what I will do is I will create another function string. So let me not write any signature here, right? Let me keep it just void for now. Let's see how
Okay.
we drive that. Get car list grouped by brand and color, right? This is what you want.
Yeah.
List of car, and then I have car list. So let me see what I have. Now I will do an operation on car list. I call a stream. I want to collect. Collector, how I will get is from collectors,
Group.
right? Grouping by. I want to call group by brand, so I say car, and then through method reference I call a brand. Now this will return me the same thing, right? It will return me cars grouped by the brand. My objective was first I group by brand and then I group by color, right? So I go to grouping by function, then I see grouping by basically takes one more argument which is of type collector itself. So grouping by returns you a collector, but grouping by also takes collector as an argument. That gives us immense flexibility. What this means is that I can actually get another collectors dot grouping by and then I say car get. Okay. So first, so I say when I want to collect, I want to collect by brand, right? So I collect by brand. Then I say
Okay.
I want to do further grouping. If you want to do further grouping, then pass one more collector which is of grouping type. Now, if I want to group, I want to group by color.
Okay.
Okay, now let me drive its signature, right? Let me try to make a guess what it will actually return. So when I was grouping by brand,
Two values. Two.
exactly. So that's what exactly. So this is what I will get, right? I will get a list of cars by brand, right? So if I was just grouping by brand, this is the signature that I will get, correct?
Yeah.
But if I am grouping by two values, then what I will get is string, comma. The inside values of this will be another group,
Yeah.
which will be list of cars
Another map is coming up. Okay. Okay.
by brand and color. And if I say group by brand and color equal to this, now it is not giving me any compilation error because my method signature is actually matching exactly with what it is actually returning.
Yeah. I think you have done a lot of work on this Java 8.
Yeah, I've done some work here. It takes time basically. I mean, to be very honest. I mean, it's not a. But depending on
Because
use.
I was eagerly watching how you, that two parameters, how you will return that value.
Okay. So yeah, it takes a while basically because it's a different paradigm actually, right? And this basically initially it's very confusing, but once you like start utilizing it on a daily basis,
Yeah,
one or two functions at a time, then it will take you probably 2 to 3 weeks to get the concepts.
concepts, yes.
So this is how we get the this is and then you can this so this is infinite, right? I mean grouping by you can keep calling. You can keep passing, you can keep calling, you will keep getting map inside map inside map inside map.
Okay.
Okay. Right. So we have seen okay, I am like tired speaking.
Okay, no problem.
So basically, so like in Java 8, right? So there are like three topics that we have covered. There are three more topics that we have to go through. The first three topics that we covered, are about streams. Streams are the most important, features of Java 8. Okay.
Mm,
Other features are, important, but they are not as important as the streams. And for
okay,
example, Java Datetime API, right? Java Datetime API earlier was very confusing, but now they have created a new class, new package called Java.time. Okay, so earlier dealing with dates, between different time zones was very difficult, and we will see an
mm,
examples of it. How Java Datetime API actually helps it. But most of the
mm.
people that I have worked with, that most of the companies that I have worked with, they were always using a library called Joda Time.
Yeah, correct. We are also using the same.
Okay, so Joda time basically solves most of the problems, whatever deficiencies were there in the Java datetime API. So the
Yeah.
datetime API that has actually come in Java 8 is actually already very late. Okay,
Mm-hmm.
but still it's a part of the curriculum. So we will basically go through the some of the APIs. But Joda time is basically a superset of the Java datetime API. So if you are using already Java datetime Joda time, then probably you don't even need to look at the Java datetime API.
Okay.
Okay, so that's the concept behind the new Java datetime API. This we will cover through some examples because part of the curriculum. File IO again, we will spend like half an hour on this. Okay, um, half an hour, 45 minutes on file IO, and we will see examples of what are. So this one is important, right? I mean, unlike Java time API, for file input output, whatever new features are there in Java 8, there are actually no alternatives available. Okay,
Okay.
because now file IO APIs, what they do is they actually return you the streams, and streams are the new concept, correct? So that is
Yeah.
the reason that file IO is basically important, and we will go through the examples of file input output API because you deal with the files all the time, right? I mean, there is hardly any project where you are not reading or writing some files.
Mm,
Okay, and parallel stream is basically that if you want to divide your work into multiple codes, then you can utilize parallel streams. But parallel stream is something that we will cover, but that is more helpful when we understand the streams properly. Okay, because parallel streams sometimes may produce result which is unexpected, which the program looks correct, but then it does not behave the way you expected.
okay.
Okay, so sometimes they are very dangerous also. So until you have a grasp on the streams, generally you should not try to use the parallel streams. That would be my suggestion at least too. Otherwise, your program may do something in production that did not actually expect, and it will be very difficult to identify what actually happened.
Yeah.
Okay, so so lambda operations, so the streams we have covered in detail. Java Datetime API and File IO. I want to cover like half an hour, 45 minutes on each of them. Look at through examples and see what are the new things that are actually there, and then we will work for some time on parallel streams. And after that, I would like to have some questions from you. If you write some code, probably I will try to review it. If you So that's the way I design the program, that you will write something and then we will review it together, so that
Yeah.
concept
Mm,
is clear, right?
can we that once we finish the class and then I start picking up from the first onwards, because I'm a little bit I understood whatever you are teaching, and but my way of if I want to learn, then I have to see your first videos, and then from the very beginning, I have to code and do the coding. And so once I keep coming up with the concepts, then I'll shoot out questions to you through email or something.
Sure, sure. Yeah, yeah. That's perfectly fine with me. I don't have absolutely no issue.
Yeah.
Okay. So, okay. So now, you want to like take a break, or shall we capture these two? In the Because I'm worried that if we like do too many things, then they may get jumbled up.
Can we do this in tomorrow?
Yeah, I think so. Yeah, that I think would be even much better.
Yeah. Basically, um, if I frankly speak, I didn't sleep
Yeah.
because
No,
we had a guest, and by the time I am in another time zone, and uh, thought to attend the class, so
correct.
uh, I didn't sleep at all the whole night.
Oh, is it?
I was completely attending, and so it is just because of your class and that interaction that made me to wake up like this. Otherwise, I would have gone in between. So it is good. Thanks.
Okay. Okay.
So
Okay.
that's why maybe today I may not get enough time again
Sure. Sure.
to
Understood that.
go
No
through
problem.
the
So
things.
you are like you have been permanently shifted to Ireland, or like you went on a short term project on.
No, I'm permanently here.
Okay, you are permanent. Okay. Okay.
Yeah,
So no problem. Let's meet tomorrow. I mean when you are fresh, and then touch base upon these topics and discuss some doubts, right?
yeah, sure, sure, 100%.
Okay. Okay, Manjush. Have a good night.
Thank, thanks a million. Thanks a million.